Today we're going to talk about writing the solution reactions of salts in aqueous solutions. You have to understand that the salts we're talking about here are actually ionic. And as you can see here, the structure of ionic salts is that they are composed of alternating cation and anion. So the blue here, let's say we're talking about sodium chloride. So let's write it. Sodium chloride solid. Now you can see here that the blue positive ion represents sodium ion, and the green one is represented by the chloride ion. And there's an alternating positive and negative in the whole crystal structure of the salt. And these ions are held by what we call electrostatic forces, where the positive is attracted to a negative. When sodium chloride is dissolved in water, we can actually represent that a symbol like sodium chloride aqueous. But in reality, when you talk about sodium chloride aqueous, this actually refers to a sodium ion and a chloride ion dissociated in solution. As you can see here, that the sodium ion is surrounded by the water molecule, and the oxygen side of the water molecule, which is more negative than the hydrogen side. And so the oxygen, which has a more partially negative charge, is now attracted to the positive charge of sodium. As you can see on the chloride side, it is the hydrogen that gets attracted because hydrogen has a partially positive charge, and since the chloride has a negative charge, they get attracted to each other. So this is how a positive and a negative ion in solution is surrounded or are surrounded by water molecules. Now, the goal really is for us to be able to write dissolution reactions like this. So, sodium chloride solid is dissolved in water, but we will not show water anymore. It can dissolve into its component ions, sodium and chloride. And we should be able to match the relative number of the cation and the anion based on the formula of the salt. So in this particular case, sodium chloride is composed of one sodium and one chloride. And so when it dissociates into solution, you're going to have, for every one formula unit of sodium chloride, you're going to have one sodium and one chloride in the solution. Some books will actually write this as sodium chloride solid becoming sodium chloride aqueous. It's just the same thing. But of course, if you want to put more information on what ions are present, then you have to write them as sodium ion and chloride ion so that it gives more information. So, let's try to solve dissolution reaction or write dissolution reactions. So let's start. For example, like I told you, sodium chloride solid. You need to remember which one is the cation and the anion. In this case, it is sodium as the cation. We write it that. And then chloride as the anion. So that's how you write the solution reaction for sodium chloride. How about if we have magnesium chloride? Remember here, it's going to be a little different. Why? Because the magnesium chloride has two chloride ions. And so it will dissociate into magnesium 2 plus and 2 chloride ions. Now, What if I have, let's say, aluminum chloride? So it will dissociate into aluminum 3 plus and 3 chloride ions. What if we have, let's say, a more complicated ion, like let's say calcium nitrate, solid. So remember that there is calcium as the cation and nitrate as the anion here. So we write it as calcium, okay, calcium 2 plus and 2 nitrate ions. Let's make it more complicated. How about ammonium phosphate? So make sure you know which one is your ammonium. There you go. Ammonium is NH4 plus. There's 3 of them. And phosphate, there's 1 phosphate for every 3 ammonium ion. So the most important thing here is that make sure that we recognize which one is the cation and which one is the anion. And at the same time, we must maintain the relative number of the cation and anion in your formula. So that's about it. So I hope that whatever salt is given to you, we would be able to write its complete dissociation in solution. Thank you.